So now we're going to be applying the rules that we learned in 7.1. 2 to the x equals 4 squared. So there's all sorts of ways to solve these equations. We're going to perform the grade 9 exponent laws that we did last time, most specifically change of base. So I know 4 is 2 squared, so I'm going to replace the 4 with 2 squared. And I'm going to substitute with brackets. Then on the right-hand side, I'm going to multiply my exponents together. And I can clearly see that if I have the same base, I can simply make the exponents equal to each other. Now I always want to remember anytime I have an equation, I can check my answer. So I want to take the question as is, and I want to substitute the x value in for x. And then I want to answer the question. So 2 to the 4 is 16. 4 squared is also 16, making a correct statement, which means x is correct, equal to 4. Okay, so let's take a look at another exponential equation. So again, if I ever see something without an exponent, I give it an exponent of 1. On the left-hand side, I can add the exponents. And then as we saw in the last question, if we have the same base, we can simply make the exponents equal to each other. And now I know that x is equal to 4 through algebra. We're not going to be showing very many steps. Sometimes I will bring it over, but we are subtracting 1 from both sides. Now, x is equal to 4. I'm going to simply rewrite the question that was given to me. And I'm going to substitute x that I solved for in for x. And then I'm going to answer the question. 2 to the 4 is 16, times 2 is 32, and 2 to the 5 is also 32. That is correct, therefore my answer is correct. So now let's take a look at another example. 4 to the x plus 1 equals 8 to the 2x minus 2. So I'm going to perform change of base again. I'm not going to do the work off to the right any longer, but 4 is simply 2 squared. And 8 is 2 cubed. Now I can multiply my exponents together. So on the left-hand side, I have 2 to the 2 times x is 2x, and 2 times 1 is positive 2. On the right-hand side, I can multiply the exponents together. 3 times 2x is 6x. And 3 times negative 2 is negative 6. Now I have the same base, so I can make my exponents equal to each other. So 2x plus 2 equals 6x minus 6. If I subtract 2x from both sides, I have 2 equals 4x minus 6. If I add 8 to both sides, I have, if I add 6 to both sides, excuse me, I have 8 equals 4x. Then I can divide both sides by 4, and x equals 2. Then, if I take the equation again and practice substituting my answer back in, I get 4 to the exponent, 2 plus 1 equals 8 to the exponent, 2 times 2 minus 2, which is 4 to the 3 equals 8 to the 2 times 2 is 4 minus 2 is 2, and 64 is equal to 64, which means my answer is correct. Okay, let's look at something interesting this time. 2 to the exponent x squared minus x is equal to 1. Now, we've been talking about change of base for a while. We need to keep working on that process, and we need to remember I need base 2. Well, 1 is simply 2 to the 0. Again, grade 9 exponent laws, we have to be incredibly familiar with all of them and be able to use them interchangeably whenever necessary. So, I can simply replace the 1 with 2 to the 0. Now I have the same base. I can make my exponents equal to each other. Now this looks familiar. Grade 11, factoring. I can simply factor out an x, and I get x minus 1. Then I can set my factors equal to 0 separately and solve. Now, in the notes you can see me testing all of the answers to make sure that they are the same as the original. However, I'm not going to every time. But x is equal to 0, x is equal to 1. When we substitute them back into the original equation, they are correct. So let's take a look at another. So we've got 2 to the x squared minus 3x equals 1 over 4. Now again, I've got base 2, so I need to figure out what 1 over 4 is with base 2. So I'm going to take 1 over 4 off to the right, and I'm going to start to work on it. So I know that 4 is simply 2 squared. And I know that 2 squared on the bottom is 2 to the negative 2 on the top. We can see that in exponent laws. So now I can leave the left side as it is, and I can replace the 1 over 4 with 2 to the negative 2. Now I have the same base, so I can simply make the exponents equal to each other. Now again, grade 11 factoring, I need to get this thing over to the right-hand side so I can solve the equation. So x squared minus 3x, I'm going to add 2 to both sides of the equation. Again, we're not going to show those steps. We're just going to do it. We have to be very comfortable with grade 9, 8 equations and algebra. So now I'm factoring this. And again, if you have any difficulty factoring, please review grade 10 or 11, but I'm going to simply do it in my head. So I'm going to just set up my brackets. And the only things that multiply together to make x squared are x and x. And the two numbers that multiply to get 2 and add to get negative 3 are going to be 2 and 1, both negative. Now I can set my factors equal to 0 separately, and I can solve. Again, you can check your answers to make sure that it is correct, or you can look at the notes to see the proper substitutions to make sure they are correct. Now we're going to be looking a little bit more with fractional exponents. So let's say I have something like x equal to the exponent 2/5 equals 3. Well, I want to do a process that we've done before, and I'm going to do that first all by itself. So let's take x squared equals 9. Now, we all learned back in grade 11 that we could square root both sides, and x was equal to, through processes, plus or minus 3. Now, we're going to do the grade 12 method, the same question, equals 9. Now, we're going to root both sides, but we have to remember that a square root of something to an exponent of 1, for example, is just that to the 1/2. So remember, square rooting something is just taking it to the 1/2. So I'm going to put brackets around the left-hand side and take it to the 1/2. I'm going to put brackets around the right-hand side. I'm going to take it to the 1/2. Now on the left-hand side, I'm going to multiply the exponents together. Now 2 times 1/2 is 1, so x equals. Now 9 to the 1/2 is the square root of 9, so that answer is 3. And again, we would have to remember plus or minus. So instead of rooting both sides, we're going to take both sides to the 1/2. Now, how is 2 and 1/2 related? Well, they are the reciprocals of each other, and that is the method we are going to be doing. So I'm going to rewrite the question just once this time. And I'm going to put brackets around the left-hand side of the equation, and I'm going to put brackets around the right-hand side of the equation. And the reciprocal of 2 over 5 is 5 over 2. So I'm taking both sides to the reciprocal exponent of the variable. That is in your methods. Now, 2/5 times 5/2 is 1, and that was the point of it all that we just explained off to the right. We take both sides to the reciprocal exponent, so it gets rid of the exponent of the variable. Now we just have 3 to the 5 over 2. So let's look at that a little bit more complicated. So let's take something like x plus 1 to the 2/3 equals 16. Now I'm not going to rewrite that equation, but I have a variable. I'm going to put brackets around the left-hand side, and I'm going to take it to the reciprocal exponent. If I do that to the left, I have to do that to the right. Now again, multiplying exponents by the reciprocal exponent will remove that exponent. So we simply have x plus 1 equals 16 to the 3 over 2. Now on the right-hand side, I'm going to do grade 9, 10 exponent laws. So I'm going to start off with a root. The bottom becomes the root. Good, now x plus 1. I'm going to square root the 16 first because I don't know what 16 cubed is. So x plus 1, 4 cubed is 64. And then if I subtract 1, I get 63. Again, check your answer. You can see all of the checked answers in the notes, but correct. Now we're going to look at more complicated equations.